Okay, here we go. This is the review for Module 6 test. I'm going to start with number 19. I basically skipped all of the multiplying, adding, and subtracting polynomials. If you guys have questions on those, you can always ask me in class, but those should be easy enough. Like all of these, I just skipped them. Okay, I'm starting with number 19 in this case. So 19, Carlita has a rectangular swimming pool. This is actually an adding polynomials problem. Okay, so it's actually the same stuff that you saw in problems 1 through 18. So it says Carlita has a rectangular swimming pool in her backyard that has a length of 24 feet and a width of 12 feet. I'm going to go ahead and draw a rectangular swimming pool. The length is 24 and the width is 12. She wants to install a concrete walkway of width C around the pool. So around the pool, there's a concrete walkway, and the length of this walkway is C. That's C. That's also C, right? The width of the walkway is C on all sides, basically. Surrounding the walkway, she wants to have a wood deck that extends W feet on all sides. So around the walkway, there's a wooden deck. And the wooden deck has W feet. The W on all sides. Find an expression for the perimeter of the wood deck. So basically, what is the perimeter of this? Basically, the larger rectangle here. Okay, so for that, what I need to do is figure out what is the new length and what is the new width, and then add up all the sides. Okay, so to start with the length, this is 24 plus, because we're adding C on both sides for the concrete walkway, that's C plus 2C. And then the wooden deck is going to be W on both sides, right? It's W on this side and another W on this side, so plus 2W. And that's the length. For the width, I'm going to start with 12 because that's the pool. And then to that, I'm going to add C on both sides, C here and C here, that's 2C. And then to that, I'm going to add W on both sides, W here and W here, so that's 2W. And so that is the length and the width. Now to find the perimeter, what I need to do is add the length plus the width plus the other length plus the other width. So add this numbers up here twice for each one, right? So add this one plus another one that is the same up here, plus this one plus another one that is the same over here. Okay, so it's basically combining like terms at this point. I'm going to go ahead and add it already. It's going to be 24 plus 12 plus another 24 plus another 12. That's going to be 72. And then it's going to be 2C plus 2C plus another 2C plus another 2C, giving me 8C. And then it's going to be 2W on this side plus 2W plus 2W plus 2W, giving you a total of 8W. And there's your answer, which is C. Okay, let's continue number 20. A market analyst has projected that the cost of producing D dog leashes will be given by the polynomial 9,000 plus 3.2D. So D represents the number of leashes. The revenue generated from the sale of D dog leashes will be given by the polynomial D times 15 minus 0.00005D. Which polynomial expression represents the profit earned from producing and selling D dog leashes? So here is where you have to know this situation. If you know how much money you make or you bring in into your business, that's called the revenue. The money that you have to pay out, either for wages or for rent or for whatever you need to pay out from your business, is the cost. And what the money you get to keep after that, right? Revenue is how much money your business brings in. Take away the cost, which is money that you have to pay out, and that is basically your profit. That's what you get to keep. So following that, it says here that the cost of producing the leashes will be 9,000 plus 3.2D. So they're giving me, in this case, the cost is this. So I'm going to put that here for the cost. So it's going to be minus and then 9,000 plus 3.2 D. Also, they are giving me that the revenue is this amount right here. So I'm going to plug that in for here, right here in the revenue. So that's going to be D times 15 minus 0.00005D. Close the parentheses. And the total of those two will give me the profit, which is what I want. Okay, so to start this, first I need to make some space over here. So to start this one, I'm going to go ahead and distribute the D. D times 15 times 0.00005D. Okay, so that's going to give me 15D. I'm doing this. I'm distributing the D right here and right here. Okay, 15D minus 0.00040 5D squared. And to that, I am going to subtract 9,000 plus 3.2D. When I subtract that amount, I'm basically subtracting 9,000 and subtracting 3.2D. So what I need to do is combine 15D minus 3.2D. 15 minus 3.2 is going to be 11.8D. This 0.00005D squared is not going to combine with anything else, so it's going to still be there. And same thing for the 9,000 here. Negative 9,000 will not combine with anything else, so it would still be there. So basically, this is your solution. It's not in standard form the way I have left it here, but it's basically going to be this amount right here. This one would be first because it's D squared, then this one, then this one. So negative 0.00005D squared plus 11.8D minus 9,000. The only one I see that looks like that is C. So that's your answer. Okay, let's move on with number 21. A rectangular garden has a length of 5a plus 17 feet. So I'm drawing a rectangular garden here. This is 5a plus 17, and that's a 5. And the width is 4a. 4a right there. Which expression represents the area? Well, that's actually going to be easy. Area is length times width, right? So just multiply those two values. 4a times 5a plus 17. Or 5a plus 17 times 4a. Distribute and you're done, right? Distribute the 4a there and there. 4a times 5a is 20a squared. 4a times 17 is going to be 68. No, 68a. Done. Which means that your answer is B. Okay, I'm moving on with number 26. If 2x squared minus 5x plus 7 is subtracted from 4x squared plus 2x minus 11, what is the coefficient of x in the result? So here it's telling me to subtract. You got to make sure you pay attention to which one is being subtracted from which one. It's this one minus this one, because it's saying that this is subtracted from this one. Okay, so you basically are going to have 4x squared plus 2x plus, minus 11 minus 2x squared minus 5x plus 7. You're doing that subtraction. And this minus, remember, in front of parentheses, you need to distribute it. So it's going to be 4x squared plus 2x minus 11 minus 2x squared plus 5x minus 7. And then just combine like terms. 4x squared and negative 2x squared combined together to make 2x squared. 2x and 5x together makes 7x. And finally, negative 11 and negative 7 together make negative 18. The question is, what is the coefficient of x? So if you look at which one is x, is this one. The coefficient is 7, so your answer is B. Alright, I'm continuing with number 28. It says, which divisor of 2x cubed plus 2x squared minus 5x minus 1 results in a remainder of 86? So this is the last section that we covered. Okay, you need to take this negative 2x cubed plus 2x squared minus 5x minus 1 and divide it by all of these to see which one will give you a remainder of 86. Okay, now there are two ways of doing this. You could use synthetic division, which is the last thing that we covered, or what you can do is plug in these numbers, but the opposite of these numbers, into this function right here and see which one of them gives you 86 as a result. Like this. For example, I'm starting with A. If I want to check if this will give me a result of 86, I would plug in not 3 but negative 3. And remember I said that this is the reason for this is because you're thinking if x plus 3 is a factor, then that means that the solution would be x equals negative 3. Take negative 3 and plug it in there and see if it gives you 86. If so, you're done and it's A. If not, you would try negative 2. And if so, that means that the answer is B. If that doesn't work, then try C, for which you would try positive 2. If that works, then your answer is C. And then if that doesn't work, you go to D, which is positive 3. Okay? So that's one way of doing it. Plug in negative 3, plug in negative 2, plug in 2, plug in 3, until you get 86. Okay? The other way of doing it is with synthetic division, which is the way I'm going to do it right now. With synthetic division, what you're going to do is, same numbers, this would be negative 3, negative 2, positive 2, and positive 3. This one's negative. And you're going to try to do synthetic division with those. So watch. I'm going to use negative 3 as my divisor. My numbers here are going to be negative 2, positive 2, negative 5, and 1. And I'm going to use synthetic division. What I'm looking for in synthetic division is this last number, right? That's the remainder. If I get 86, I'm done. If not, I check another one. Okay, so here we go. Synthetic division. First, bring down the first number, negative 2. Then you're going to multiply the negative 3 times the negative 2 and write your answer right here. Okay, so negative 3 times negative 2 will give me 6. What you're going to do now is combine these two right here. 2 plus 6 gives you 8. And then do the multiplication again. Negative 3 times 8 and write the answer right here. Negative 3 times 8 gives me negative 24. Negative 24 and negative 5 combine to make negative 29. And again, repeat, multiply negative 3 times negative 29, which gives you positive 86. Oops. 86. Nope, that's wrong. 87. Let's undo that. 3 times 9 is 27. 3 times 2 is 6, so 87. And then you combine the positive 87 and the positive 1, and that gives you 88. And so you don't want 88, you want 86, which means that it's not A, and then we repeat. We do it again. Okay, so let's do it again. I'm erasing these numbers. And I'm erasing this because now I'm testing negative 2. Not 2. Like that. Okay, so let's do it again. Bring down the negative 2. Multiply negative 2 times negative 2 gives you 4. Combine the 2 and the 4 gives you 6. Let me repeat that again. Bring down the negative 2. Negative 2 times negative 2, 4. 2 plus 4, 6. Negative 2 times 6, 12. Put a 12, negative 12 right there. Negative 12 and negative 5, negative 17. Negative 2 times negative 17, positive 34. And 34 and 1, 35. So that's not what I want. I want 86, so it's not B. Let's do it again. Try 2, right? So for x minus 2, I'm trying positive 2, and then we do it again. Bring down the negative 2. 2 times negative 2 is negative 4. Negative 4 and 2 is negative 2. 2 times negative 2 is negative 4. Negative 5 and negative 4 is negative 9. 2 times negative 9 is negative 18. Negative 18 and 1 is negative 17. Didn't work. It's not C. It has to be D. But just to be safe, let's check it. Okay. So let me erase this. And we're trying positive 3. Okay, so bring down the negative 2. 3 times negative 2 is negative 6. Negative 6 and 2 makes negative 4. 3 times negative 4 is negative 12. Negative 12 and negative 5 is negative 17. 3 times negative 17 is going to be 3 times 7 is 21. 3 times 1 is 3, negative 51. Hey, what happened here? That doesn't work. Did we mess up? So it's not D. Then we messed up on one of the earlier ones. Alright, you know what? I think it might have been the first one then, because it was pretty close to the actual answer. So let's check that one again. Instead of 3, negative 3. Okay, and let me erase these. I think maybe that's the one that was closest. So let's just double check, because we might have made a mistake. I might have made a mistake. Bring down the negative 2. Let's do it slowly now. Negative 3 times negative 2 is 6. 6 and 2 makes 8. Negative 3 times 8 is negative 24. Negative 5 and negative 24 is negative 29. Negative 3 times negative 29 is going to be 3 times 9 is 27. 3 times 2 is 6. 87. Oh, I see the mistake. Does anybody else see it? I hope you saw it before I did, because it's been taken. This problem took way too long, way longer than it should have. Okay, I see the mistake. The mistake is when I wrote these numbers here: negative 2, positive 2, negative 5, negative 1, not positive 1, and therefore I made a really dumb mistake, which caused my problem to last longer than it should have. Negative 1 and positive 87 are going to be 86, and that's your answer. Which means that A is correct. Okay, so once again, when you check these, make sure you're checking the opposite sign, right? If you're checking x plus 3, you plug in negative 3. Okay, you put it in here in synthetic division, or plug in negative 3 into the x values here to see if you get 86. You should get 86 if you do it that way as well. So plug in negative 3 here, or use synthetic division with negative 3 and look for the remainder to be 86. Okay, let's do another problem just like the last one. Which of the following is a factor of this? Okay, which means can we divide these by these factors here? Now the question is different from number 28. Number 28 said if we divide, is the remainder going to be 86? And this one is just saying, are they factors or not of this polynomial? So when they say which of the following is a factor, what they're really saying is when we divide this polynomial by these, do we get a remainder of 0? Because that's what it means to be a factor. Do you get a remainder of 0? So you're really checking if the remainder is going to be 0. Let me put that here to remind myself. I'm looking for remainder 0. And once again, I'm going to check them by using synthetic division. But when you check these, remember to change the sign. So when you do the first one, x minus 2, you're going to use positive 2 as your divisor. The next one is going to be negative 3, positive 3, and negative 2. We'll check all of those, okay? And once you're really good at synthetic division and you're not making those silly mistakes like the one I made in the last problem, it should be a lot faster to do. Okay, here we go. We're going to do 2, and my numbers are 3, negative 10, 3, positive 10, and I'm being extra careful to check my signs here so I don't mess up like before. Bring down the 3. 2 times 3 is 6. Negative 10 and 6 is negative 4. 2 times negative 4 is negative 8. Negative 8 and 3 is negative 5. 2 times negative 5 is negative 10. 10 minus 10 is 0. There it is. A. Now this is a multiple choice question, not a multiple response question, so I'm done. If it was a multiple response question, you would have to continue checking each one to make sure that they're not actually solutions as well. Okay, so once again, what does it mean when it says which of the following is a factor? What it really means, when we divide by these, do we get a remainder of 0? That's what it means to be a factor. Okay, so you get 3, -4, and -5. Now what does this actually mean? It means that when we divide 3x cubed minus 10x squared plus 3x plus 10 by x minus 2, we get this, which we can translate into 3x squared minus 4x minus 5, and no remainder. Okay, and maybe we could even continue breaking this down by using any of our factoring methods, either factoring by grouping or x factor, as some of you guys know. Maybe we could continue breaking this down, and we could actually factor this completely using this method. Okay, let's continue with 31. Which of the following is not a factor of x cubed minus x squared minus 14x plus 24? So instead of asking me if they are factors, it's asking me if it's not a factor. So in this case, we're looking for the remainder to not be 0. If we get remainder 0, that's not the one we want, because that means that it is a factor. We got to keep going until we find a remainder that is not 0. Okay, so I'm going to do the same thing, synthetic division here. For the first one, I'm going to use -1, then I'm going to use +2, then +3, then -4. Alright, let's start with -1. My numbers here for my polynomial are 1, -1, -14, and 24. Bring down the 1. -1 times 1 is -1. -1 plus -1 is -2. -1 times -2 is 2. -14 and 2 is -12. -1 times -12 is 12. 24 and 12 makes 36. There it is. A is not a factor because I got a remainder of 36. Let me just double check that real quick just to make sure. 1, -1, -14, 24. Good. You're dividing by -1. Bring down the 1. -1 times 1 is -1. -2. -1 times -2 is 2. -14 and 2 make -12. -1 times -12 is 12. 24 and 12 makes 36. That seems right. That means that everything else, if I divide it into the polynomial, should give me 0. Okay. If they don't, then something's wrong with the problem, but they should give me 0. Okay, I'm moving on to 36. What is the remainder when 2x cubed plus 3x squared minus x plus 1 is divided by x plus 3? I'm going to use synthetic division again. You could use long division, but synthetic division is so much easier, especially since I'm dealing with a binomial here where x, the coefficient of x is just 1. Okay, so I'm going to use synthetic division. Your numbers are 2, 3, -1, and +1. And you are dividing by x plus 3, which means that the number here on your corner should be -3. And here we go. Bring down the 2. -3 times 2 is -6. 3 and -6 is -3. -3 times -3 is +9. -1 and 9 is +8. -3 times 8 is -24. And 1 and -24 is -23. There's your answer. There's your answer, B. Done. See how simple those are with synthetic division? Okay, I'm moving on to 39. If x minus 2 is a factor of a polynomial, okay, so I'm going to stop right there. Stop reading right there. If x minus 2 is a factor of a polynomial, that means that when I divide by 2 in synthetic division, not -2, by +2, I get a remainder of 0. It also means that when I plug in 2 into my polynomial, I will get 0, okay, which is basically what the remainder theorem says. So if you substitute in 2 into your polynomial, you will get 0 if it is a factor. Which of the following statements does not have to be true? Okay, so A is saying if you substitute in 2 into your polynomial, you will get 0. That one has to be true, because x minus 2 is a factor which translates into +2. That means when you plug in 2 into the polynomial, you will get 0. B, when you substitute in -2 into your polynomial, you will get 0. That one does not have to be true. It's possible that it is, but it doesn't have to be true. Okay. 2 is a root of f of x. Well, if 2 is what I get from x minus 2, that means that when I plug in 2, I get 0. So it's called a root. And it's also called a 0. Both A C, and D have to be true. They are all true. B is the only one that could be true, but we're not sure if it is or not. Okay. So the question is, which of the following does not have to be true? The only one is B. 40. Write a quadratic function in standard form having zeros of 3 and negative 1/3. So a quadratic function in standard form having zeros of 3 and negative 1/3. That means that the zeros are these numbers, and which means that if you can go backwards, in order to get x equals 3, that means you started with x minus 3. Right? Think about it. If I start with x minus 3 equals 0 and I solve it, that means x equals 3, right? But I'm going backwards. So that means that I started with x minus 3. In order to get negative 1/3 as my 0, that means I started with x plus 1/3. Right? So those are my two factors, and I need to figure out what my function is. All you got to do is multiply those two things, x minus 3 and x plus 1/3. Multiply them out, and you should end up with the correct function. So let's multiply here. X times x is x squared. X times 1/3 is 1/3 x. Negative 3 times x is negative 3x. And negative 3 times 1/3 is negative times positive, negative. 3 times 1/3 is just 1. Combine like terms, negative 3 and positive 1/3 x. Well, you know what? Before I do that, I'm going to multiply everything through by 3, because that will cancel out that fraction. And I notice that in my answers here, none of them have fractions. So in order to make my job a little easier, I'm just going to go ahead and get rid of the fraction by multiplying everything by 3. So I'm going to go ahead and multiply everything by 3. You can do that because you basically have a function and you're just increasing it by 3, which is not going to change it much. Okay, 3x squared plus x minus 9x minus 3. Now I can combine, this is 3x squared. Now I can combine the positive x and the negative 9x into negative 8x, and I'm done. 3x squared minus 8x plus 3, which is, wait a minute, something's wrong here. Let's try that again. Negative 3 times 2, it's going to be negative 3x. Oh, I see the mistake right here. This is a negative sign, not a positive sign, so this should be minus 3, not plus 3. Let's just fix that real quick. So minus 3. So then there's the answer, 3x squared minus 8x minus 3, which is A. Number 41, for p of x, a polynomial, equals 4x cubed minus 28x plus 24, p of negative 3 equals 0. Okay, let's break that down. What does this mean? It means that when I plug in negative 3 into my polynomial, I will get 0, which means that negative 3 is a 0 or a root of my polynomial. When I plug in negative 3, I get 0, which means that negative 3 is a 0. Okay. It also means that when I put this in synthetic division, negative 3, my remainder at the end will be 0. Which means that minus 3 goes into this polynomial, so x, not x minus 3, but x plus 3, which is where the negative 3 came from, right? If you solve this, you will get x equals negative 3. That's where the negative 3 came from. So that means that x plus 3 is a factor of the polynomial, which is d in this case. Okay, so a lot of information is given in this little point right here. When they say negative 3 is a 0, or negative 3 gives you, that means that x plus 3, which is this basic 0 as a factor, the x plus 3 is a factor of the entire polynomial. Right? If they said p of negative 2 equals 0, then I would say x plus 2 is a factor. If they say p of 5 equals 0, then I would say x minus 5 is a factor, and so on. Okay, 89. Completely factor 4m to the fourth minus 324. Okay, now in order to factor this, you need to be able to identify that 4m to the fourth is a perfect square. because 4 is a perfect squared, it's 2 squared. And m to the fourth is a perfect squared. It's basically taking m squared and squaring it, right? So since both of those two things are a perfect square, that means that the whole thing is basically 2m squared squared. It's a perfect square where your base is 2m squared. You also have to identify that 324 is a perfect square, which is 18 times 18, or 18 squared. If you see that, then you can factor it. If not, you're going to be stuck for a while, right? So 2m squared squared minus 18 squared. Since they're both perfect squares, you're going to break that down into two sets of parentheses, 1 plus, 1 minus, 18 on this one, 18 on this one, 2m squared on this one, 2m squared on this one. And there's your breakdown. Okay, but you could go even further, because on the second set of parentheses you have a negative right here, which means that you're subtracting these two things. So if you could factor out a 2, for example, and we are going to factor out a 2. Actually, both of them can be factored, so let's factor both of them. I'm going to divide out 2 on both of them. So that means that this one is going to be 2m squared plus 9. And the second one is also going to be 2m squared minus 9. Now these two 2's that came out are going to get together and become 4m squared plus 9. And this m squared minus 9 is going to break down even further. Since it's a difference of two perfect squares, you should be able to see that this becomes m plus 9, no, m plus 3 and m minus 3. And there's your basic factorization here. I see m squared plus 9, m plus 3 minus 3, b. There's your answer. Number 90, determine whether 14x squared minus 25y to the 16th is a difference of two squares. If so, choose the correct factorization. Now this one you got to examine it carefully. X squared is a perfect square, 25 is a perfect square, y to the 16th is a perfect square. If you wanted to break that down, it would be y to the 8th squared. And that's how you would write a perfect square, right? It has a 2 as an exponent. But 14 is not a perfect square. Don't get confused. Don't think it's 7 times 7. 7 times 7 is 49, not 14. Okay? So since this little number right here is not a perfect square, you're going to choose no. If it was 49, then definitely go ahead and break it down. Okay, moving on to number 97. When x to the third minus 125 is written as a product of a binomial and a trinomial, what is a trinomial factor? So we have x cubed minus 125. That is a perfect cube minus a perfect cube. So I'm going to go ahead and break that down. Since it's a perfect cube, I can write it like this. X cubed minus, and 125 is a perfect cube. It's 5 cubed. A perfect cube minus a perfect cube. So when you have that and identify it, you do this. A binomial and a trinomial. In the first binomial, you're going to put x and 5. And the sign is going to be the exact same sign as the one you started with. In the second, in the trinomial over here, you're going to take the x and square it as your first term. For your last term, you're going to take the 5 and square it, so 25. And remember, that one's always positive. For your middle term, you're going to take them both and multiply them times each other, so 5x. And that one is going to be positive because the sign is always going to be the opposite of this sign. Same sign, opposite sign, always positive. So the question is, when you do this factorization, what is the trinomial factor? So not this one, but the trinomial, x squared plus 5x plus 25. B. 101. Which of the following expressions can be rewritten as a sum of cubes a difference of cubes, or a difference of squares. So go one by one and see if they match any of these categories. A, 81 minus x to the fourth. 81 is a perfect squared, so perfect square, so it's 9 squared. And x to the fourth is a perfect squared. It's x squared squared. So that is a difference of squares, right? That's that one. Done. B, n to the sixth is a perfect square. It's n to the third squared. And 64 is a perfect squared. It's 8 squared. However, it doesn't fit into any of the categories because this is a sum, to the plus sign, of two perfect squares. We always want a difference, meaning a minus sign, of two perfect squares. So B does not fall in the category. C, y to the fifth minus 9. There is no way for me to write y to the fifth as a perfect square. Also, no way for me to write it as a perfect cube. Okay, so that one does not fall in the category. You know what? Let's go back to B. I just noticed something on B. It is not a difference of squares, but maybe we could write it as a sum of cubes. Because I'm noticing here something. Let me erase it. It doesn't work as a difference of squares, right? We know that. But n to the sixth, we can write it as n squared cubed. So that's a perfect cube. And 64 is 4 cubed. So that's a cube plus a cube. So this is a sum of cubes. So B actually does match the categories. Okay, C, we already said no, and there's no way for me to write that y to the fifth. Moving on. D, 5 minus 4c to the 16th. 25 is 5 squared. That helps. 4 is 2 squared. That helps. And c to the 16th is c to the 8th squared. Therefore, everything is perfect squares. There's a negative sign right there, which is what we should have. So D falls under the difference of squares category. E, 5p to the third plus 27. P cubed is a perfect square. Perfect cube. 27 is a perfect cube. It's 3 times 3 times 3. But the 5 is what throws this one off. So no, this one doesn't fall under that category, any of the categories. And the last one, 216 minus t to the 18th. You need to check and find out if 216 is a perfect square. 15 times 15 is 225. 14 times 14, I think. No, 14 times 14 is 196. 15 times 15 is 225. So 216 is not a perfect square. Is it a perfect cube? 5 times 5 times 5 is 125. 6 times 6 is 36 times 6. Let's check that. 6 times 6 is 36. 6 times 3 is 18 plus 3 is 21. There it is. 216 is 6 cubed. It's a perfect cube. Which means that I can write t to the 18th as a perfect cube. 18 divided by 3 is 6. So t to the 18th is t to the 6th cubed. Right? Because I want to write it as a perfect cube since 216 is a perfect cube. And there you go. You have a difference of 2 cubes. So F also falls. A, B, D, and F fall under the categories that they asked us for.